Hi and welcome back to Learn Python by Doing number 13. So finally, we are going to talk about decorators. So they are extremely useful, so pay close attention to this. In Python and other programming languages, like for example JavaScript, we can pass functions as arguments to other functions. This is because everything in Python is an object, including functions. Functions are also objects, so that's why we can also pass functions as arguments to other functions. We have already seen this with functions like filter and map. So remember, the first argument of filter is a function. It can be a lambda function or it can be an ordinary function, but you get the point. The first argument is a function and the second argument is the iterable. Such functions, that means functions that receive arguments, functions as arguments, are called higher order functions, and you may have found abbreviations like HOF. So every time you read this in an article or in a book, HOF means higher order functions, and they are very common. So HOF can return functions as well, as we saw already in closures. And the definition of decorators. Decorators are higher order functions that takes a function as an argument and adds some extra functionalities and returns it. As simple as that. So let's see an example of our first decorator. First, we have to define the outside function like we did in closures, and it's going to receive a function f as an argument. Okay, now we're going to define the inner function, which right now is not going to take any argument, and we're going to print I am a decorated function. Decorated function. Finally, we execute or call f and return the inner function. Okay, so far so good. Okay, now we have to do the following thing. We have to define our hello world function or whatever you want to call it. And this is not going to receive any parameters, and it's just going to print hello world, as simple as that. Okay, now let's create another function. So I'm going to call it decorated hello world, and we're going to call wrapper with hello world as a function. Now we just called this function here, and this is the result. I am a decorated function hello world. Okay, so first let's see what's happening here. Here we called this decorated hello world with no arguments. Why is that? Because here we're simply executing this inner function or calling this inner function. So the inner function doesn't have any parameters, and that's why this function doesn't have any arguments or parameters. Okay, so this is how decorators work. And there is a syntactic sugar that you may have seen that instead of doing this, wrapping the function and calling it, we simply do this wrapper, and that's all. So now we simply call hello world, and that's all. I am a decorated function hello world. So by doing this, we are calling the inner function of the wrapper directly. So this is a syntactic sugar. They like it to call it like that, syntactic sugar, to remove unnecessary code. Okay, so that's what decorators are. Now let's see another example, but with parameters. So now the inner function is going to receive parameters, okay? So let's again define a wrapper function. It's going to receive a function as an argument. Now the inner is going to receive two parameters. So the function that we're going to pass is going to have two parameters or 2 arguments. Okay, so first, before coding the decorator, let's define the function that we want to decorate, which is going to be a simple divide function. Okay, so we're going to return a divided by b, as simple as that. And obviously, if you divide by 0, then you will have an error. So you may be asking, why just you don't do this? If b equal to 0, print we can divide, um, else return a divided by b. Okay, we can do this, but suppose that we have another function, like for example, complicated operation that again receives a and b, and it's doing some complicated thing here, and at the end returns something that resembles a divided by b. So we have to do the same thing here, and we are duplicating code. So there's this principle called DRY, don't repeat yourself. And that's when decorators come in handy, because they allow us not to repeat code. So, okay, we can do this, but we're not going to do this. So return A divided by B. And okay, here we're going to say if b is equal to 0, then we're going to print we cannot divide by 0, or we cannot use 0. We cannot use b as 0. And we're going to return anything, and else then we're going to return f, a with the 2 arguments, a and b. Okay? And finally, we're going to return the inner function. As simple as that. Now we decorate this function here with a wrapper, and we call it like this. Okay, so first, let's call it with 1 and 5. It's 0.2. Now with 1 and 0, it says we cannot use b as 0, and it didn't return anything. And as I told you, we can use this wrapper with complicated operation, which is not necessarily dividing by, but b cannot be 0, and then we're using this same code. And if we use b equal to 0, the same message is going to appear. So it allows us to not to repeat code. Okay. Okay, so the last thing that we are going to see in this video is to put in practice what we learned about arcs and quarks. So let's define again our wrapper function. And this time we're going to measure the time that it takes for the function to execute in seconds. Okay, so we're going to define the inner function here, and we don't know nothing about this function. We don't know which kind of function is, how many parameters it takes, so we can simply say arcs quarks. And by that, we are guaranteeing that it can be any function. So here, actually, we have to import some library here. So it's the first time, I think, that we import something. And we're going to say start time.time. Then we are going to execute this function. We pass arcs and arcs, and finally we measure the end time and print this. So we're going to use f strings here. This function took end, so time, execution time. We're going to define this variable, which is going to be end minus a start execution time. Okay, finally we have to return the inner function. We wrap any kind of function here actually, so suppose square root, I don't know, square root no, let's call it complicated operation. Okay, so this is going to receive A, B, and C. And the first thing that it's going to do is A plus B plus C, then R is going to be multiplied by A, then R is going to be divided by C, and finally it's going to return or print R. Okay, so let's pass complicated operation 5, 8, and 10, and 19, sorry. So as you can see, the result is 8.42 and the function took 0.0002. I think this is seconds. I'm not completely sure, but I think it's seconds, so 7.67 times 10 to the minus 5 seconds. Okay, so that way you can use this wrapper function with any function you like, independently from their function signature. That means independently for their arguments and so on. So this is everything I need to tell you about decorators. See you in the next video.